Good morning. Shall I wait a second, Stefan, or we start? Okay. So, here it comes. So what I would like to do this morning is quickly take you through where we stand with the NEO development as such. But after the development comes the industrialization, and for sure comes the ramp-up, which is equally important to us. Then we'll take you quickly through the performance improvements, which I will less touch on what you may expect, the fuel burn, because here we are very good, but we are as good also on the so-called low-speed performance. And then give an outlook what it takes to make a NEO and why the NEO is a very tasty and good recipe. First, very simple, when we talked at the same place last year at the Innovation Days, we were just at the end of finishing the detailed design of the A320. We are just about to do the same now with the A321, which is a little bit different compared to the A320 and A319, which are very similar. And now a year has passed by, and so what did we do? We finished off the detailed design of the A320. We went into the final assembly line, so we did for sure all the section builds before. We did the same with the engines. We went very successfully through the engine test program. We then, in spring this year, started the final assembly of the first aircraft, and now you can see we are just very short before first flight, which is going to happen in September this year. Very important. And I highlighted this already last year, that we are very satisfied with the current aircraft definition, because for sure our commitment is to deliver a 15% fuel burn improvement at least. And as I'm standing here, I can confirm, yes, we do it. And we are not doing it on the back of any further modification. So the aircraft, the first aircraft that you're going to see in a minute, is something which is as good as any aircraft we could and would deliver to a customer. So there is no further modification needed on this aircraft, because this is really on performance. Giving a little bit more physical evidences, so a lot of pictures which are all quite recent. Some of them are already 3 to 4 weeks old. So I started on the left side. You see our aircraft, which is about 1 kilometer from here. MSN 6101, the first NEO aircraft, readily assembled, and you can see it's in the loads calibration, which is something you need to do to calibrate all your indications. I was told not to become too technical this morning. Anyway, it's a sign that all the so-called flight test installation is already installed. So if you would have a look inside the cabin, you would see large screens, displays, and computer racks. And this calibration test is now to, you can only do for sure when all of this is installed, is now to calibrate all the sensors. We have about 3,000 sensors all over the aircraft, including the engine, and to make sure that the indications we are getting when we go to flight are the right ones. On the upper right, you see two pictures of Pratt engine. They are both in Toulouse since a couple of weeks. The left picture of the two is when the engine arrived, which was already in April, so quite a while ago. And the upper right one is taken about 3 weeks ago, when the first engine was readily podded. Podding means you put all the pipework and stuff on it. You put the nacelles around, and you also paint the nacelles, which is done for the first engine, and as we speak it's also done for the second engine. Both engines are in the final preparation, and in 4 weeks from now they will both be under the wing, and the aircraft will be painted and will then really look like the first NEO. The two lower right pictures, for sure, the second engine to come, the LEAP 1A. We have 4 engines already in test since quite a while. 3 of them are in the US, in the GE facilities, and the one you see on this picture is called engine 10. And has been assembled in Villaroche, which is close to Paris, at the SNECMA facility, the other part of CFM. And this engine is currently in the test process, and it's also running very well. And on the lower right side, what you would also maybe be interested in, is the assembly line for the air inlet for the CFM engine, which we are doing in our own facilities. So which is a critical know-how, and we believe we are very good at that. What we are also very good at is industrialization in automotive principles. And here you see the so-called acoustic panel line, but it looks similar for the overall assembly line, which is really like an automotive facility. Yeah? So you have lots of KUKA robots, you have not so many people anymore involved, and it's really a fully automated process to make a technically extremely complex part. Hopla. Okay, ramp up. I guess you are aware of the 2,700 orders. Here they are. We have taken in the meantime firm commitments with customers bringing us into the comfortable position to have a 60% market share in this segment of re-engined, super modern single-aisle aircraft. And you see that we also plan a ramp-up, which is for sure needed to honor all those commitments we have with our customers. And it's quite a steep ramp-up, which is challenge number 3. Challenge number 1, get your performance right. It's a tick in the box. Make the entry into service on time. I would also say it's a tick in the box, because we are so good on schedule. I don't dare to hesitate to say, yes, we will make an entry into service in October next year. Then a mature product, I will come to the maturity in a minute, and then for sure to stem the ramp up, because the aircraft will only be delivered if it can be produced, which is challenging, but we are not running naively into it. And I want to show you on the next picture that also for the industrial and quality and maturity side, we are innovative. Innovation is mostly associated with technical stuff, so you are designing something in a very high sophisticated way. It's less associated with industrial means. So what are we doing with the Neo? First of all, we have been very, very adamant to achieve superb quality. And we have given ourselves extremely aggressive targets for the quality of the first aircraft, and for sure for the aircraft to come afterwards. It's mostly difficult with the first one, where you have all the changes incorporated on one aircraft. And we had a target, and we have been 70% better than this target, because first time ever in aeronautics we applied advanced product quality planning, which is a standard in the automotive industry since the decade, but first time ever has been applied in aeronautics, which has only one purpose. You want to design and produce your product right first time. Yeah? So you don't want to go to iteration loops, and this is what we have achieved, which is also a fundamental prerequisite for a ramp up, because if you need to change your product while ramping up, you will start stumbling. Second one, we are an aircraft manufacturer. We luckily have done lots of new developments in the recent past, and the Neo is just one more. So you are well advised to take the lessons learned from the recent developments, and so we have screened everything we have done on A380 and on A350. For sure we have focused on the engine part, and we have screened 2,000 lessons learned. We have captured with A380, but with A350 in its test phase, and we have checked, okay, there was a finding, could be in service, could be in development, could be in test. And we have thoroughly screened, did we respect this also on the Neo design or on the Neo test? And now we are through with even more than 2,000 lessons learned, which we have incorporated in the Neo, which will help us. Yeah? We will also learn something, that's a matter of fact, but these 2,000 are already behind us. Yeah? We will not experience them again on the Neo. The last one, for the ramp up, also automotive standard is... Okay. Standard in the automotive industry is you make a pre-series, means you are not producing for the first time your 1000 Volkswagen Golf when you need them. You do this a couple of months before, and it's the same that we are doing now with the Neo. We start with complicated and complex components, and we go up the section level, including the full engine. And you can see the nice chart here, where you see these peaks going down. And you see this is basically is a sequence of the takt time for the assembly of the different components as we need them. And you see the peaks going down is that we make a test, a discrete test, at a much higher rate than we need at this moment in time, in order to check if the whole industrial system, everything is okay, which is, are the parts good, are the assembly drawings good, are the assembly lines okay, are the fitters rightly trained, is the logistics okay, all these things. This is what we are going to do. Means when we are going to the ramp up to the rate 46, we will have experienced the rate 46 quite a while ago. And we can take lessons learned, there will be lessons learned, we can incorporate them before we really need the industrial output. Performance. The Neo is all about performance, and I'm not, as I've said initially, going back to the 15%, which we comfortably beat. On fuel burn, we have also looked into how can we reduce the cost per seat. And reducing the cost per seat is very simple, you put more seats in. Where we have been limited by the evacuation limits of the different doors, and our doors, the first and the last door, which are all the same on AC19 2021, they were certified as a type C door, which has a certain evacuation limit, but in fact the door was even larger than a type B door. So what we have done, we have conducted discussions with the authorities, and we have agreed on a test program with them to prove that we should not limit the evacuation limit of those doors to what they are today, that we could further enlarge them, which we have done. And you can see the comparison of our AC20 door and the Type C door. So in fact, it's larger than even a Type B door. And tests have led to the conclusion that with the door as it is today and putting a larger slide, the one you see, the single lane slide, is a current standard, but today already airlines as an option can get larger slides, which is then a slide raft. If you combine these two, we could see that we can comfortably go beyond the current evacuation limit, and it would in fact enable us to evacuate even 200 passengers from the A320. We find this is not a convenient layout anymore, but with up to 189 seats you can comfortably sit inside. And so this is what we have now developed, and we have agreed with the authorities, and it will be available in early 2015 with first deliveries on A320. It's also valid for the A321. What did we do on top? Because you may say, okay, you are putting more sardines in the can. It's not very convenient to sit inside. But what we wanted to do, we wanted to support the higher seat count also with intelligent means to give living space and floor space to the customers. So we have reduced the working areas, which is a crew area for galleys and lavatory space, by SpaceFlex and smart lavatory yet to come. What is also very important, as we speak, we don't have these old-fashioned seats anymore where you have all the magazines and news in front of your knees, just compressing and squeezing in your living space. They are much slimmer now, and the magazines are now in the front of your eyes. So you have the living space for your knees. Then we have increased the exit limit, what I just said before, for door 1 and door 4. And on top of that, we have changed the configuration of the A321. I will come to it in a minute, the so-called Airbus Cabin Flex. And if you put all of that together, by the way, the Airbus Cabin Flex was also enabled by the increased exit limit. And to keep the comfort level, we have the 3 ingredients mentioned before. If you look at it, how does it look like? We have now 2 overwing exits, so it looks a little bit like an A320. And due to the increased evacuation limits, we could eliminate the door number 2, and this is very attractive because this is the area if you have a 2 or 3 class layout where you want to position your business or first class, and it gives you a lot of flexibility to install seats, because always when you have a cross aisle which you need to preserve, if there is a door that you need for evacuation, you have a limitation in your layouts. So this limitation is fully gone now, so comfortably and easily you get 6, in certain cases even more additional seats into the ACF. And then there is also an opportunity to suppress the door number 3, which is the rear one, which is circled in here in yellow. You can do it, and you can even put a plug in, so it looks like a normal fuselage, and you have a full-size window in it. All in all, this brings the A321 from 220 seats to 240 seats, and if you compute this, for sure there is a little bit of weight that you carry, and the passengers have their weight as well, but it gives you about 6% seat fuel burn reduction only by adding more seats into it. If we now look at the achievements on the Neo as such, the new engine introduction, and we are particularly good also on the A321. We are way above 20% for seat fuel burn if we compare it with the current aircraft. You will say yes, but who wants to sit in that? I volunteer. I'm 186 tall. Yeah, it's not. I think it's already quite a bit. But it's not a problem. If you see where we gain space, you can see with Space Flex and with SmartLav, we are gaining space in the rear end. And you simply see that you have much less interruptions of the floor space by cross aisles. So in fact, in the end, if you want to put 240 pax into the A321 ACF, you can do it consistently with at least 28 inch. You don't need to have a single seat row which has less than 28 inches. If you then account about 1 inch for slimline seats, which you have for the knees but also for the eyes, and if you then consider that for sure on this aircraft we always have the 18-inch seat width, and we have traits which prove, and it's really a scientific proof, if you have 18 inches instead of 70 inches seat width, the comfort perception is at least good for 1 if not 2 inches in pitch. Means the experience, the comfort experience you will have in this aircraft due to new monuments, extending the usable area, eliminating cross aisles, keeping the big seat widths, gives you a comfort experience which is well in the range of 30 inches. And that's why we think, and we are very confident, there will be a high take-up rate for this layout, because it's not really compromising on the comfort. Next one. We had, Neo is heavier by definition, the engines are much larger. So we have an increase of weight which is in the vicinity of about 1.6 tons, which is just induced by the larger engines and nacelles. And our ambition was always keep the same takeoff and landing performance, so that the airlines, when they fly in Neo, can host the same number of passengers under similar assumptions between a CEO and a Neo. So we didn't want the airlines to pay a price by taking passengers out. This was our top-level requirement, which we have met, but then we have said, this aircraft, even if already very good, has a lot of potential to go beyond, and we should not only look at high-speed performance, which is the famous fuel burn, we should also be looking at the low-speed performance, and we in fact put a lot of efforts into the Neo, which is about aerodynamic optimization. It's improving braking capability in the aerial phase, but also in the ground phase. It's adaptation of control laws, many other things. And I just took 2 examples which are very prominent because it's very prominent routes out of Santos Dumont. An A320 Neo can lift off and land 34 pax more than a CEO could do. And for the A321 Phoenix, which is also a very hot airport in Las Vegas, you can put about 25 pax more under the same operational conditions, so same temperatures, etc. Which is very good news, and this is also explaining why we have on the Neo such a trend to the big aircraft. Because when you are takeoff or landing limited, sometimes you were forced to stay with an A319 or with an A320, but you could not take the bigger aircraft because you couldn't host the passengers. Now, with about 30 pax on average more, it starts absolutely making sense to start thinking about larger aircraft. Yeah? And this is a big contribution, so it's for sure it's value add for the customer, because this is drastically reducing the seat fuel burn on top. But it also makes sense for them to say, okay, should I consider an A321 instead of an A320, or an A320 instead of an A319? Environment. This is all about what we are doing. You may know the figures. Fuel savings is equivalent to CO2 emissions, 15% at least. And it's going beyond. You see what we are saving in tons of CO2 and how many trees you would have to plant to absorb this CO2. We are also very good and exceed our commitments on the noise and also on the emissions. Noise. Also, the A321 has a comfortable margin against Chapter 14. It's with the highest thrust. It's the most noisy aircraft, but the Neo will comfortably meet with all types, including the A321, the ICAO Chapter 14 requirements, which we would not even have to meet, but for sure we want to be ahead of the demand, and here I think we are the front runner in terms of eco-efficiency. Recipe for a successful Neo. So this is a cook, and I don't want to play it down, yeah, but if you want to have a tasteful meal, you need to have good ingredients, so you need to have good materials, and you need to have a good process, which is the cooking instructions. So what do we do with a Neo? And we may consider also in the future, it makes sense if you have a good platform. If you have a poor platform, putting new engines on a poor platform still makes a poor aircraft. So it must be reliable. It must have a good customer base. Our customer base is very large. You will see 52 customers, which is about double what our competitor has. We have the 18-inch comfort, which is enabling us to keep the comfort level even by further optimizing efficiency. We have fly-by-wire, introducing what I've just said, low-speed performance with fly-by-wire is comparably easy. If you have old-fashioned mechanical controls, it's much more difficult to achieve the same performance. Lightweight. We are well above, well below our weight targets, and the aircraft I've just shown, the ACF A321, it's about 300 kilos lighter even than the current A321 is. And for sure you need the new engines, because this is what a Neo is about. But what do you have to do? You have for sure to integrate. Integrating does not only mean you plug the engines under the wing. Everybody can do that. But if I tell you that in the integration of the engines, you have at least 2 to 3% fuel burn at stake. If you get it right, you will get it. If you don't get it right, you will have more fuel burn. And we are confident we have driven this really to an extreme. And this is where our know-how sits, and this is where we are differentiating from the competition. Optimize aerodynamics, flight control, and weight. Easier to do if you have a fly-by-wire aircraft. We are very good on weight, so we have not sacrificed. We had to sacrifice a little bit because the engines are heavier, but we could compensate in other areas of the airframe. System upgrades we have done. We have been moderate with it because we wanted to keep our 95% commonality target, which is a commitment we have with our customers, and we are meeting even this. We want to minimize weight increase. I've already said, okay, and then you put it all together, you let it cook for about 4 years. And then I can only say, bon appetit. Thank you.